All right, we're going to go into the first router, which is labeled as router 0. So let's go ahead and click on that. And let's set up our window so we can actually see our information. Let's just open it up a little bit here if the mouse wants to work with me. All right. And the command to look at our topology table is show IP EIGRP topology. Now, this is a pretty big topology table, so we'll scroll up a little bit. And let's take a look at the codes first. There's two codes that you're mainly concerned with. The P, right? And you see it up here. And the A, which you don't want to see. What does that mean? The passive means that the routing protocol already found all the networks that exist. So no need is not actively looking for that particular network. Everything has been converged already. So that's what the P is, and that's what we want to see. If taking some sort of a certification exam or in a real-world scenario, you happen to run into this situation and you have an A, definitely there's something going on within your network that you're not receiving the information from that particular side. So you troubleshoot those routers over there. So these two are your main two that you want to look at. The next thing that we look at, I'm going to scroll down. You see all these numbers right here. This FD is the feasible distance. This number, it's a calculation. It's part of a math that happens that it comes out with to calculate the metric. You can see that the feasible distance is also the same number over here. The topology table is going to hold all the routes for all existing paths to all the networks. All right? The good paths and the slower paths. But the routing table, and let's take a look at that. And you can see here real quick as I scroll down before we go to the routing table that to the 200 network, which is this, though, not the 100, the 200 somewhere over here, you see there's two paths that you can go. You can either go through the 10116, which is this way, going up, or the 101129 going down. So there's two ways to go. Which is the one of the two that's going to make it to the routing table? Well, it's going to be the one with the lowest metric. And if you look at it, or the feasible distance right here, this looks like it's lower than this one, right? So this one should be in the routing table. And this one is considered a feasible successor. And we'll talk a little bit more about the feasible successor later on. So let's take a look at now at the routing table and let's prove to see who's there. So let's do a show IP route and let's open this up so we can see it better. All right, so we see the 200 network and we see this number, this 3589120. Well, is that the number that we saw earlier up here? Sure is. There it is right there, 3589120. So that is the successor route. That is the route that actually made it to the routing table because it's the best path. The other route is considered the feasible successor, which is the backup route. In case something happens, and this is what's so great about the topology table and within EIGRP, that if for whatever reason a link, let's say this is the successor route, is going up this way, happens to fail, then what happens, the EIGRP will actually look at the topology table and query it and say, hey, there's another route that's available for me. Let me pick it from the topology table and just dump it onto the routing table. Instead of having to recalculate everything all over again, it will use that. So the topology table is really something very helpful that EIGRP uses to go ahead and create or have backup routes waiting for us to use instead of having to recalculate. But your design has to be made that way. So you need to go ahead and have this redundancy within your network. So the next thing that we're going to look at, we're going to go ahead and take a look at the feasible successors now that we've looked at the topology table.